Video 6, Inverse Functions. The proper name for the opposite operation is an inverse function. You have been dealing with inverse operations in maths already. For example, adding and subtracting are inverse operations. Multiply and divide are inverse operations. Square, square root, sine, inverse sine. The inverse is written with a little -1 for the sign. Therefore, if we have a function f, we can write inverse of f with the same superscript -1. This denotes the inverse function. Function is the f, and this one is inverse function. Inverse of f. Now, not all functions have inverses. The ones that do, will have a one-to-one correspondence between the numbers going in and the numbers coming out. X in, f of x out. If the numbers in the domain match the one number in the range, then we can find the inverse function, which takes you back again. So f operates in this direction, and inverse of f takes us back. More simply, if you have the input or the domain or x travelling in this direction, f takes us to output, the range, or f of x. The inverse can take us back again. For example, if you take a function where you add a number, to go back again it's a subtract. Multiply by 3, to go backwards you divide by 3. That reverses the process, or becomes its inverse. On page 27 we have the function f of x is equal to 2x plus 4. If we drew this on a graph, we would have gradient 2 and intercept 4. Crosses at 4. So this would be y equals 2x plus 4, the straight line. If we would like to draw its inverse function, we can do this just by drawing a dotted line along y equals x and imagining this is a mirror. All inverses can be drawn by reflection in y equals x. So instead of 4 on the y-axis, the 4 maps down to the x-axis. And we have a similar line like this. This is a graph of the inverse function. We can work out what the inverse function actually is using a process. The process to work out the algebra of the inverse function is as follows. We take f of x, 2x plus 4, and replace the f of x with y. Now we'll replace the x and the y. We're just going to swap them. Swap the x and y. Now that means on the left we have y, so we will just put that as x. And here we're going to change the x into y. So it's really just changing the letters round without doing any maths at all. The next thing, we need to swap sides. 2y plus 4 goes on the left and x goes on the right. Again, that's not really doing any maths, we've just swapped the left hand sides around. Swap left, LHS is left hand side and the right hand side. Now we need to do transposition. So in the end we want to have y appearing on the left. In order to do that we're going to add 4 to y. Add 4 to the left makes a 0 in this position. So that's a subtract 4 from both sides. So we have x subtract 4 on the right. Now we're going to divide by 2. Divide by 2 to get y on the left by itself. X subtract 4 divided by 2. Final stage, instead of writing y, we write inverse x equals x subtract 4 over 2. Page 31. F of x is half x plus 4, and we would like to find the inverse function. First of all, we'll replace f of x by y. And swap x's and y's. Now I'm going to swap sides. Left hand side and right hand side have been changed. I'm going to transpose for y. So I need to subtract 4 from both sides. Half y equals x subtract 4. Now multiply by 2 both sides. We have 2 times a half is 1. So y appears on the left. And now we have 2 multiplying our bracket. You can leave it with a bracket in its factorised form or write 2x subtract 8. Final answer, we need to replace our y with the inverse function of x equals 2x subtract 8. Page 32. The inverse of 3x cubed plus 1. We start by replacing f of x with y. Now we swap the x's and y's. 3y cubed plus 1. I will swap sides also. 3y cubed plus 1 equals x. Now the proper math starts. To transpose for y. Subtract 1, both sides. Remember to do the same operation to both sides of the equation. Divide by 3, divide by 3. On the left we have y cubed. X subtract 1 divided by 3. Y cubed, we need to take the cubed root to get back to y. Cubed root of x subtract 1 all divided by 3. Final step is to replace the y with f inverse x equals the cubed root of x subtract 1 over 3. Page 33, example 3. The inverse of f of x equals 2x plus 1 over 5x subtract 3. Find the inverse. Replace the f of x by y. Now I'll swap x and y. Swap the letters. 2y plus 1, 5y subtract 3. Now I'm going to begin the algebra to get y on the left hand side and x on the right hand side. This is going to take a few stages. So I'm going to multiply by 5y subtract 3 because it's the denominator. Multiply top and bottom by 5y minus 3, and that means we won't have any fractions. So the left hand side is 5xy subtract 3x, just writing that without a bracket. Same bracket on the top and the bottom means these two cancel, and we're left with 2y plus 1 on the right hand side. Now I'm trying to get y on the left, so we're going to move negative 3x, this one. We need to put that on the right hand side, so we'll do that by adding 3x to both sides. 5xy equals 2y plus 1 plus 3x. Now 2y, we'd like to have that on the left, so we subtract 2y from both sides. 5xy subtract 2y equals 3x plus 1 on the right hand side. The left hand side, we'll need to take y as the common factor, 5x subtract 2, because y appears in both 5xy and negative 2y. Right hand side is 3x plus 1. Then we can get y by dividing by the bracket 5x subtract 2. Almost done. Just rewrite this. Inverse x is 3x plus 1 all divided by 5x subtract 2.